Okay, moving on. So our first step, this guy right here is in the cytoplasm, and then the rest of it is in the mitochondria. It's either in the matrix of the mitochondria or it's in that inner membrane. I wasn't fancy enough with my graphics, but both of them happen in the mitochondria, those last two steps. So this very first step right here, this is glycolysis. This is step number 1, glycolysis. So this is what's going to happen in the cytoplasm. C6H12O6, which is glucose. Okay, that's one of our reactants. I'm going to write glucose. It is broken down. Okay, it's split in half, and 2 molecules are made. Each of those molecules has 3 carbons. Okay, which makes sense because this guy's got 6 carbons. So this guy is going to break down and is going to produce 2 molecules, each with 3 carbons. And each of these are called pyruvate. Pyruvate.
Excuse the interruption. At this time, we need seniors with the last name E through H that wants to get a cap and gown picture taken. Please go to the Ox Gym. That's E through H. And also, we need International Thespian Society, Drama Club, and Improv Club. Please go to the Ox Gym.
Okay, so glucose breaks down into these 2 pyruvate molecules. Okay, this breakdown also produces 2 ATP. Now, the whole goal of cellular respiration is to produce as much ATP as possible. Okay, that the whole process of cellular respiration is breaking down sugars, which is glucose, to produce ATP. Okay, because we have to store energy somehow. Okay, the other molecule, we actually have 2 molecules. I just kind of ran out of room. We are going to produce 2 NADH molecules. Okay, they carry some energy. Okay, but NADH is a big electron carrier, and he also donates these hydrogen. So I'm just going to put over here electron carrier, and he is going to donate his hydrogen ions. He's going to be needed. So he's a donator, and he is a electron carrier. Okay. That is glycolysis. That is essentially where glucose is first broken down. Our next stage right here, okay, I'm going to put stage 2. This is the Krebs cycle. So now we have moved into the mitochondria, and we are going to take our 2 pyruvate molecules with us. So this guy is going to be transferred here, and this guy is going to be transferred here. So these 2 molecules are going to move into the mitochondria. So I'm going to write pyruvate and pyruvate. These 2 pyruvate molecules are going to further break down. Okay? They are going to break down into ATP. Three CO2, so 3 carbon dioxide molecules, and that's one of the waste products, okay, of cellular respiration. So 1 pyruvate molecule will break into an ATP, 3 carbon dioxide. It's going to break into total of 4 NADH. So I'm going to write 2 NADH. Again, those guys are going to help carry the electrons we need for later. Same with the hydrogen. So 1 pyruvate is going to break into ATP, 3 carbon dioxide, a total of 4 NADH, 2 here, and 1 new molecule called FADH2. He is also an electron carrier and a hydrogen donator. He has the same function as NADH. Okay? Because when we get over here, we're going to need some electrons and we need some hydrogen. And those guys are going to provide it for us. Okay? Now I'm going to repeat the same thing. Each pyruvate molecule produces 1 ATP, 3 CO2, 4 NADH, and an FADH2. Now the whole idea behind cellular respiration is to produce ATP, and we're producing some of it, okay? We've got 2 here so far, we've got 2 here so far. So the bulk of our ATP is actually going to come from the electron transport chain, okay? The purpose of these molecules being made is to use the electrons and the hydrogen over here, okay? So we can make ATP. That's the purpose of making them over there, okay? This section right here, I'm going to put number 3, ETC, which is the electron transport chain. And we will save that for tomorrow.